p.1s. Wait, both of these are integers. p.1s. Oh, those are floats. Man. Okay, you can pass 1's a D type. So do int64, numpy.int64. Okay, so now they're integers. Great, so those are the negative indices. Now I can do delete b.a range for like 10. Then those negative indices. Oh, this is too large now. So I guess this has to be like 30 or something. Okay, then I get the indices. Okay, great. So then the ones from the R that I want is just R IDX. Although I don't know if these lengths are quite right. I put out 1s times plus this times 3. The index array will have to be the same length as the array. So that much is clear. The negative index array is not the same length as the array though. So how long is it? I can compute the final value of the index array is going to be like length of the negative index array plus 1. Wait, length of the... It's going to be this minus 1. That's the index of the last one. It's going to be that times 3 plus 1. And I want this to equal the length of the array minus 1. So I need to solve this for the length of the negative index array. Okay, so I can take off a 1. So that's minus 2. I can divide by 3, so I get this. Wait, let me do one step at a time with this. So I'll divide it by 3. So I'll get that. Then I'll add 1. Well, that's a really weird expression. But whatever works, I guess. I assume this is integer division? But okay. Maybe I should just make it long enough or something like that. Okay, so back to this. I'm definitely gonna want to try this on the square example first. Because this could get complicated. Because this could get complicated. And then I'll take out these. Okay, these are the points of the square. Actually, even if I did that, they still wouldn't be triangulated. Well, they still wouldn't be triangulated. But what could I do then? I think there should be some trick to insert in the origin point. Oh, I actually only need the index array. I only need this. Then I can pass that to OpenGL. So maybe that's fine. Actually, as an easy test, what happens if I just put in an extra coordinate? So let me take out this debugger. Okay. Put in an extra index. And it's still fine. Thank you, OpenGL. Or ModernGL or something. So going over isn't a big deal. I'm just gonna put the origin point here, the -1, 1. I'll just make that... No, not 0. Although, actually, if I put the origin point here, I'll just do that with an O at the beginning. Now... Oh wait, this is worse. Because then I'd want the 0. It'd be like O, comma. No, this is better, because I'd want the origin point, then the 0 point, then the end point, then that point. Oh wait, no, this wouldn't work. Because I want the origin point before each pair. So yeah, that wouldn't work. Oh well. I wonder if there's a way to interleave arrays. That's cute. Efficiency is not intuitive, it's always worth it to use time it. Jeez. Okay, I gotta try to get it working before I worry about any of that. So let's say negative indices. Is this np.ones? And what's the length of that? Is there an easier way to tell the length of this? 3, 5, 8. Three, 5, 8. I guess not really. It's mostly the length divided by 3, I guess. I can just do the length divided by 3 plus 1. Let me see. No, there'll be a negative index for each tuple of each triple. Each triple will have a negative index. Oh, but I didn't add the points to be excluded. So I have to have some random control point here. So it'll look like this. Here, the control to here, here to here, here to here, here to here. Okay. Now there's a negative indices for each triplet, 1 for each triplet. So it is length divided by 3. That's it. So I can get the actual indices. Doing mb.arange. There should be d-type equals... Actually, I'll try it without the d-type first. And this will be square chords at shape at 0. Delete the negative indices. Okay, so that should give me the indices into this array that I want. So here, I'm gonna put a breakpoint, and then I'm gonna look at square chords at indices. Oh, this can't just be len. Square chords dot shape. I should just have num or something. So there and there. Delete. Okay. This touchpad has no shape. Let's make this a numpy array. And there is a problem with one being an integer. Well, I'm not sure where. I guess the number was this an N32? Oh, this division. Okay, a little bit closer. Okay, a little bit closer. Okay, so then the arrays must be integer Boolean type. Yeah, so ones will have to be int 64. Okay. Should have printed that, but I'll just look at it. Now, is this the same thing I had over here? Minus 0.3, 0.3. I really need these side by side. Oh, that's right. Okay. So minus 0.3, 0.3, 0.3, 0.3, 0.3, 0.3, 0.3, negative 0.3, 0.3, negative 0.3, negative, 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 negative again, the negative positive. Okay, so this is right, which is great. What is this? Break pane? So then I need to add in the origin points. Or not necessarily. I need to add in the index of the origin point before each of these. So if I just append the origin point to the end, which would be fairly simple to do, it'd be very simple to just append the origin here. Whoops. Wait, where did I go? Okay, so I gotta append the origin here. It could be... I'll just make it 0, 0. Honestly, I could just make the origin be one of the control points. Could do that. But I think the easiest thing right now is to just try to have this indices array and then add in a some index before each pair. So how can I do that? I do np.empty. I think that would do it. So let me do... Okay, so I'm going to just put the origin point here for now. That'll be 0, 0. The square chords. I think the rounding that gets added from adding this extra point will be removed when I do this floor. When I do this integer division, so that should be fine. So then I have to do triangulated indices. Do numpy.empty. And and 64 probably. And then what size should I make this? I think it's just the size of NP of the indices array. Well, not quite. Indices shape at 0. Then how many points am I going to add? And the answer is 1 for each triple. So it's gonna be this. Isn't it just the square chords array divided by... No, it's just the length of the square chords array. Like -1. Because I'm gonna, instead of a control, I'm always gonna have the index of the origin point. So I think all I need here is num square chords. -1, just because I added the origin here. I think. Okay. So then I'm gonna rerun this. So here's the indices. Square chords at the indices. Oh, what happened? Do I want to print square chords of the indices? Not sure what I did there. And then I need to... Okay, so those indices are good. Then I need to add this 24 or whatever. 25, I guess. No, I think it'll be 24 before each of these. So I have triangulated indices. Which weirdly looks overflowed or something. I guess because it's not zeros. So some of the values are random. Now if I want to start at 0, go to the end and jump by 3. I want this to be, I guess, 24. Okay, so that's good, because it has the origin point, empty, empty, origin, empty, empty, origin, empty, empty, and that does that to the end. So I will want at 0:3 to be the length -1. Like so. Okay. Then starting from 1. I don't know how to do this other expression. How I can put like how I can like skip 1 and then put in, just fill in these gaps with the current indices. I guess I could just do it twice. Oh, there's an np.insert. Do it twice. Oh, there's an np.insert. Let's see if numpy.insert does any good here. Insert values along the given axis before the given indices. So this, I'm going to insert A15. No, I do not understand this. 151. I guess 2, 2, 3, 3. So just put a 5 in index 1. Interesting. Just putting this at index 1. Where's the array? So this is the array A. It's inserting a 1, 2, 3 column in index 1. Okay, that makes sense, I guess. Is that helpful for me though? And I think it is actually. Because I think I could just take indices. Do numpy.insert indices. Then an object defining the indices, which is 0, 2, etc. So np.arange indices.shape at 0 over 2 times 2. And these are the places where I want to insert it. Okay, and then the values. It's just 24. This thing needs a D type. I'll just put int64 here. I think this worked. 2402, 2435, 2468. I don't know what's going on at the end though. 24, 21, 23. Is it just too long? Or 24, 21, 23. Even that's too long. I want like this. These off by ones are gonna kill me. Wait, that's still not right. 24, 21, 23. I just don't want one of these to be here. It's one thing too long. Maybe actually the indices was already too long. This np.insert is a good idea. Let me look at indices. This includes 24, and I don't think it should. 2 and 3, 0 to 0, 2 to 3, 5 to 6, 8 to 9.